So now that we know what to do with products, I mean, the next kind of obvious question is, okay, well, how about quotients? And I'm going to break with my pattern here a little bit and not do a derivation of this. Most textbooks, to derive the quotient rule, they use the definition, and they do something similar to what we did with the product rule, only messier, because you can see the result here is not quite as pretty. There's actually a way that's not necessarily easy, but it's a little more straightforward. But to do it, we need something called the chain rule, and that's what we're going to talk about in the next lecture. So I'm actually going to put off proving this for now. Right? We'll look at the rule. We'll do some examples because this is the obvious thing to do next after the product rule. Then when we get to the end of our chain rule discussion, we'll talk about how we can actually derive this in a reasonably straightforward kind of way. Okay, so what we have here is we have a situation where we have a quotient, right? We have this function f, and it's equal to one function divided by another, and we want to differentiate this. Well, first, when we do this little caveat here, assuming that the derivative of the numerator and the derivative of the denominator exist, then this is the derivative, and the way I remember this is it's the bottom times the derivative of the top minus, and then you reverse it. It's the top times the derivative of the bottom, and then it's the bottom squared. The thing that was in the bottom stays in the bottom, and its exponent just gets increased by 1. Okay, and this is a tricky one because we're subtracting. And subtraction, unlike multiplication like we had with the product rule, subtraction isn't commutative, so you have to be sure you get these in the right order. It has to be the bottom times the derivative of the top, then the top times the derivative of the bottom. Okay, so let's look at some examples. Right, I've got a pretty straightforward one here, right? I've got just kind of a basic rational function. And this is our u of x, that's the numerator. And this is our v of x, that's the denominator. And I want to find f prime. Right, well, f prime of x is the bottom times the derivative of the top minus, and then do it the other way around, the derivative of the bottom times the top over the bottom. I shouldn't write it like that. I'll make you think it's the second derivative. Let's write it like this: v of x squared. Okay, so what are our pieces? Well, u prime of x is 3x squared, and v prime of x, see, this comes out a little nice, right? V prime of x is just 1. So if we put these into our formula here, right, this is x plus 1 times u prime, that's 3x squared, minus v prime, that's 1, times u of x, that's x cubed plus 1, over x plus 1 squared. And now it's just a little algebra, it's just some cleanup. Distribute the 3x squared, 3x cubed plus 3x squared, and then distribute the minus x cubed minus 1 all over x plus 1 squared. And let's see, combine the x cubes there. 2x cubed plus 3x squared minus 1 over x plus 1 squared. And that's it. That's my derivative. Not hard, right? Not really hard. The hardest part of the whole thing is just remembering the formula, right? And being sure you get the subtraction in the right order. All right, so let me give you one, right? Take this one out for a spin, see what you come up with. Then start it up again. We'll go over it together. All right, so let's see. My numerator, that's u of x, that's x to the 4th third. We're going to fractional exponents right away. Then this is my denominator, v of x, that's x squared plus 1. And now I know my derivatives. V prime of x is 2x, and u prime of x is 4 thirds. X 4 thirds minus 1 is 1/3. Okay, so now go to the formula. f prime of x is the bottom. I'm going to leave off the of x's, right? We know these are all functions of x, right? So a lot of times when we know what it's a function of, we'll just leave the of x part off, especially when we're doing something kind of big like this. It makes it less cluttered. So this is v times u prime minus v prime u over v squared. So v, that's x squared plus 1. U prime is 4/3 x to the 1/3 minus v prime is 2x, u is x to the 4/3 all over x squared plus 1 squared. Okay, now we got to clean up this top, right? We got to clean this numerator up, and it's going to be a little messy. We're going to have to dance with that 4/3 in there for a little bit. Right, but let's see. First thing I'm going to do, and just work with me here. This is, I probably mentioned this before. You've heard me in other lectures. I'm going to do kind of an unusual factoring thing, but it's a thing that you need to get used to seeing because it comes up in calculus problems, and it's going to be really important to be able to do this when we start talking about applications. I'm going to factor x to the 1/3 out of the numerator. Right, so this first part, all this left is 4/3 x squared plus 1 minus 2x. Now look, x to the 4/3. That's x to the 3/3 times x to the 1/3. So it's that x to the 1/3 that I brought out. And all that's left is this x to the 3/3, which is x all over x squared plus 1 squared. Okay, so this is now I got to handle this fraction, and I'm going to do kind of a similar thing. Let's factor out a 1/3. Right, this is 1/3 x to the 1/3 for x squared plus 1. All right, now this is 2x squared, right? Okay, so I factored out a 1/3 from that. What's left? Well, this is going to be minus 6x squared. And you can check that real quick. Distribute it back in. 1/3 times minus 6 is minus 2. And this is all over x squared plus 1 squared. Now, I'm going to bring the 3 down to the bottom. The x to the 1/3 stays where it is. And here I've got 4x squared minus 6x squared. That's minus 2x squared plus 4 over x squared plus 1 squared. And I'm going to stop there. Now, I know some professors, when they get to this point, they're going to say, well, it's not fully simplified. Let's distribute the x to the 1/3 back in. I have great faith that you can do that properly. Right? You can distribute it back in, add the exponents, you're good. I'm going to leave it the way it is because I know where we're going. I'm looking ahead. I know that when we start talking about applications, a really common thing to do is going to be to set this derivative equal to 0 and solve that equation. The solutions to that equation are going to be really important when we start talking about applications. So I'm looking ahead and I'm saying, like, I know I'm going to want the factored version of this thing. So leave it alone. This is really the version that I'm going to want to end up with. Right? So this is where I'm going to stop. Okay, so how about this thing? Okay, yeah, this is a little messier. Now, this is a thing you need to get used to seeing, right? I have multiple things going on here. On the one hand, I have a quotient. I'm dividing here. So I'm going to use the quotient rule. But on the other hand, up here on top, I have a product. So I'm also going to use the product rule, right? So let's see. Let me clean this up. I'm going to do the quotient first. All right, so this is my u of x, and this is my v of x. And I need these derivatives. Well, let's go ahead and do u first. U of x equals x squared plus 1 times x minus 1. This is a product, right? So I'm going to use the product rule. The derivative of the first part is 2x times the second, plus, then it's the first, that's x squared plus 1, times the derivative of x minus 1, which is just 1. All right, so this is 2x squared minus 2x plus x squared plus 1. 2x squared plus x squared, that's 3x squared minus 2x plus 1. And there's my derivative. Excuse me, I didn't write it up here. That's u prime. All right, v prime is easy. V of x is x squared plus 2. V prime is 2x. Let me draw a line here, right, so we keep both of these clearly separate. All right, now I can go to my derivative, right? F prime, according to the quotient rule, is v times u prime minus u times v prime over v squared. All right, you see, now here's where it really helps to be organized with these things. It really helps to be able to just look at my calculations over here and say, okay, v is x squared plus 2. U prime is 3x squared minus 2x plus 1 minus u is x squared plus 1 times x minus 1. And what else do I need? V prime is 2x all over v squared. That's the original denominator, x squared plus 2 squared. And now, I'm not seeing any neat factoring tricks I can do. Hold on, what's this factor to? Does this factor? This is 3x plus 1, x minus 1? Minus, oh, no, it's not, because I got to have a plus 1 at the end. Darn. If I could have got an x minus 1, then life would have been easier. I could have factored it out. Unfortunately, we don't. So I'm a little stuck. I have to multiply these out. And I don't know if you, let's do this first part. I don't know if you've ever seen it done this way. This is how I like to multiply polynomials. I'm going to do this just like you learned how to multiply all the way back in the 3rd grade. Right? I'm going to do 3x squared minus 2x plus 1 times x squared plus 2. And you notice I'm setting this up just like a 3rd grade multiplication problem. What did you do when you in 3rd grade? Right? You did 2 times 1 is 2. 2 times minus 2x is minus 4x. 2 times 3x squared is 6x squared. X squared times 1 is x squared. X squared times minus 2x is minus 2x to the 3rd. And x squared times 3x squared is 3x to the 4th. Right? And then what did you do in 3rd grade? Well, you added down. 3x to the 4th minus 2x cubed plus 7x squared minus 4x plus 2. All right, so that's the first part. Now, sorry, I got to write it over again. 3x to the 4th, 2x cubed, 7x squared, minus 4x plus 2. And I don't want to keep writing that over and over again. So let me pause this if you have to. I'm going to clean this up just because I need the space. I'm going to clean this up so I can do the second multiplication. And then I'll just write that. I'm not usually a big fan of doing pieces off to the side like this, but I'm a little pressed for space here. X squared plus 1 times x minus 1. That is x cubed minus x squared plus x minus 1. And there's still that minus out in front times 2x. So if I distribute minus 2x into here, this is minus 2x to the 4th plus 2x cubed minus 2x squared plus 2x. Now let me double check that. All the exponents went up by 1 and all the signs got reversed. Good. Now I'm going to write that in here too. Minus 2x to the 4th plus 2x to the 3rd, that's a 3, minus 2x squared plus 2x. All over x squared plus 2 squared. Now I just have to combine like terms. So the x to the fourth, 3 minus 2 is 1, so that's x to the fourth, minus 2 plus 2, well, that's nice, the x cubes go away. For the x squared, 7 minus 2 is 5, plus 5x squared, minus 4x plus 2x is minus 2x plus 2, all over x squared plus 2 squared. And that's it. There's my derivative. A little messy, right? But really, it's just applying these rules over and over again. Okay, so how about this thing? Trig functions. Again. Okay, well, we can do this now, right? We already know sine and cosine. Well, let me just put those up here real quick, just to remind everyone. The derivative of the sine is the cosine, and the derivative of the cosine is minus sine. Okay, so here's how I'm going to do this. I'm going to think of the tangent. I'm going to use the definition. The tangent of x is sine of x over cosine of x. Yeah, look at what I did. It's a quotient, right? It's a quotient, so I can use the quotient rule here. Sine of x is going to be u. Cosine of x is going to be v. So what I kind of already did the derivatives. U prime is the derivative of the sine of x, that's cosine. And v prime is the derivative of cosine, that's minus sine. So now let's just go to the formula. F prime of x is v u prime minus u v prime over v squared. So let's see. V is cosine. So this is cosine times u prime, which is cosine. Well, that's nice. Minus u, that's sine, times v prime, which is minus sine. All over v, that's cosine squared. All right, so look what I've got up here. This is cosine squared. I got two minuses here, so this is plus sine squared over cosine squared. Well, look, this is nice. Cosine squared plus sine squared, that's 1. 1 over cosine is secant. So that's secant squared x. There's my derivative of the cosine. Excuse me, I got all excited. Derivative of the tangent, right? Derivative of the tangent is secant squared. And now you have the tools that you need to find the derivative of any trigonometric function. Obviously, we've already done sine, cosine, and tangent. You can get secant, cosecant, and cotangent the exact same way, right? Just write them as 1 over cosine, 1 over sine, right? Break them down into the sine and cosine versions. Use the quotient rule, and you're home free. Now, I'm not going to do all of those. I'm actually going to leave those for exercises. We're going to go over those if you're following along on the website. But I will put them here so you have them to look at, because you do need to know all of these. They're going to come up, or they're going to come up over and over again as we go along. So write them down. Obviously, go to the website. If you're using a textbook, whatever, start practicing. I know we're adding more and more that you have to memorize here. There's actually a fair amount as you're seeing of memorization in calculus. Practice is going to really help you out with getting these formulas into your head. Okay, so that's the quotient rule, right? So now we really have 3 rules. We've got the power rule, we've got the product rule, and we've got the quotient rule, right? And we've got one more rule, one more kind of formula left to go. That's called the chain rule, right? And that's going to tell us how to find the derivative of the composition of 2 functions, right? So that's what we're going to be doing in the next lecture.